Ahudu billahi minash shayatinir rajim. Bismillah Rahman Rahim. We say Alhamdulillah, Alhamdulillah Rabbil Alameen. My name is Mr. Sharia. My contact information is researchpublishingmedia@gmail.com. Again, my contact information is researchpublishingmedia@gmail.com. This is in association with Dr. Tutor. Dr. Tutor is my educational platform where we tutor all ages from elementary to undergraduate. Dr. Tutor is actually very good. We focus on mathematics. So again, you might have some young people where you're concerned about their education, or you might be a parent and you're concerned about your children's education. And as of right now, it's a hustle of the planet society, but it's specifically a hustle of black people in America, right? From slavery. They understand that when I say they, the other races or ethnicities of people, even your own people. When you have knowledge as a black man or a black woman, and you meet a black man in America, and you meet a black man or a black woman in America that has no knowledge, then you can easily hustle them for whatever you want to hustle them for, right? It could be finances. Initially, right now, it's finances, because there's no finances, and it's a hoard of the finances. Right? But always understand the wicked hoard the riches of the planet for the righteous. So it's just a hustle of black America, because black America has a history of chattel slavery. The Bible says that we are destroyed. So that means that I can tell you anything. And that's the constant theme. You always have black people in American society being hustled. Again, when you speak about former President Barack Obama, or you speak about Vice President Kamala Harris, they have given nothing. Barack Obama as president set the planet back. Now you can say he was doing the will of Allah, right? God let Barack do what he would, and it's not really specifically him, but his voice. He is not a voice, but he's in black skin and one of the most, so we think, powerful positions on the planet at that time. But they killed the brother Muammar Gaddafi in Africa, right? And you have no one really since Gaddafi with that amount of power, illusionary power, since the brother Gaddafi was killed. And Barack has something to do with that. Now realistically, because he a black man from a Caucasian female, he not really into killing no black people. So yeah, he might feel a certain type of way, but he was on board with the murder of that black man. And again, Africa is going to progress regardless, but to set that continent back, nothing. How you going to be in black skin as a president of the country and see the atrocities committed against black Americans and just do nothing? And we, so again, now we're in a separate type of room, and I hear someone talking through the walls, So we want to stay focused, you know, just to understand. So if the voice picks up, and then we still got the Wi-Fi, right? So we don't know, but if the voice picks up on the camera, just understand. So, Dr. Tutor, who are you putting, besides yourself now, if you're a parent or if you're in control of a children's group where you're the educator, well, that's something separate. And you come to the math lectures and we talk about math analysis. Math so difficult, it make life easy. And that's what we speak on. We're trying to understand and master math analysis. It's from math, it's from God. Seek ye first the kingdom of God and all of his righteousness. And then God gives you math analysis to put your brain back together from 400 years of chattel slavery. 400 plus. We're talking about a physical bondage, being treated as an animal for 400, 300 years, and then it's a mental slavery, chattel slavery, mentally. All of this was done from the knowledge of the Bible. Okay. With Dr. Tutor, we also have a leadership conference. Now, the leadership conference is, again, real good. We specifically speak to young black men, and, I mean, you know, with no guidance. Always remember now, the book of Proverbs, Judah, Black America, Judah is the lawgiver, right? So you, in humility, to not be fragile, right? There's nothing wrong with being fragile in humility, but you still have to convey leadership to the planet. If you just look at the prophecies in the Bible, right? Black America has brothers from the Bible, the Bible language, that are getting busy on the planet. And we, with a 400-year history of chattel slavery, to be degraded into nothingness. And always understand that we talk about 1930, and God sent the brother Master Farad Muhammad, or you can say God came. See, a lot of times Master Farad Muhammad, a lot of times when we get caught up in religion, and it's not getting caught up in religion, it's the culture. Again, if you live on a planet, the planet has a culture, and that culture, if you're talking about the human being, it's not a deep progression. It's only the devil that has created death for themselves. They have only created death for themselves. That's not us, the human being. So it's the culture of the planet, right? It's your culture. How do you live on the planet in peace? It ain't got to be peace with other people initially. You first have to, again, the brothers say that self-improvement is the basis for the human being development. You can't develop outside yourself until you develop inside yourself. So if you filthy, which you are, and you're talking about 400 years of slavery, we think like animals. But you in human being flesh. You don't walk on your all fours. You walk on your 2 feet, on your legs. So if your mindset is that of an animal, but you're a human being, what do you think God gonna have fun with you and how he make you and how you looking? So you look like a beast, correct? So your culture gives life. It's a replenishing of life, right? planet over 66 trillion years, and it's still moving forward. Beauty. The human being is not created in the same type of situation. So that longevity, that life, it's your culture. But now we define culture as religion, correct? Because you will hear the argument, you know, where I'm not religious. I mean, I'm not picking, that's just what's going on. Well, I don't have no religion. Well, how can you not have no religion? That means you don't have no culture. If you don't have no culture, I mean, the planet come with a culture. You're not just up in space flying around. That's your culture. Your culture is you have to eat food, breathe air, correct? So, again, it's just understanding what's going on. So your culture, and it's your culture, that's your religion, correct? And our religion or our culture, what we don't never understand, what we don't never understand is our culture is Islam. That's our culture. Our culture is Islam. God created the planet for black people. That planet came with a certain the planet came with certain rules. And those rules amalgam into what is called Islam, or the rules of the planet, which is the culture of the human being, which is the black man and black woman of the planet, that organizes into what is called Islam. And Islam, in its generality, it means peace. So you say, because you're intelligent, you say, well, if Islam means peace, then my peace is to not believe in God and Islam and none of that. But then you look at yourself and you're a beast. You're very ugly spiritually. You're spiritually ugly, right? You're physically nasty. So all those things comes about, and then there is a God. Correct? But again, it's whether you believe or disbelieve. But we talk about the human being, we talk about the culture of the planet, which is Islam. Now look now, you can just focus on Islam, and you cannot practice like the 5 prayers a day, the belief in God and all of his prophets, the fasting and the charity and the wanting to make our pilgrimage to what our ancestors built to make prayer to God. You cannot really believe in none of that, but you can acknowledge it. And you will still have a certain amount of, when I see you in society, that's peace. Correct? Now again, that's also a certain level of hypocrisy. You know, again, in the book of Proverbs, Allah talks about the sluggard. I assume sluggard to be someone that's lazy or slothful. Now you can look at that a couple of ways, but the sluggard or someone that's slothful, right, where you just always, again now with a history of slavery, 400 years, we are physically, mentally tired. But what I want to say is this. When you talk about, when you go to where we come from, where they kidnapped us from, they took us from what they call the continent of Africa. But when you go to the northern part of the continent of Africa, they got something called Jerusalem. Jerusalem. I just recently seen this. It says Jerusalem. Now that's a modern 2024 name of a city. Now I don't know how far, because we also have Israel, and I don't know if Israel, I think they call, it's a place on the planet called Israel, but I don't know what I think it was initially called Palestine. That's probably something we should look at. But, I mean, we go farther back than all of that, but I think Jerusalem has a little bit of an antiquity on the planet within the 5,000 years. Now, I'm sure what they call Kemet. I don't think Kemet was using the word Jerusalem, but let's understand now, that could be incorrect, because what I was going to say is, Jeru is just Haru, right? And Haru is Horus. And Horus is the son of Osar and Osset, right? And these are Muslims, or these are, if you're in a Commission type society, which we are, but at that time they had a specific man and a specific woman that is supposed to represent, well, they were Jesus. I'm not going to say Jesus and Mary. They were like, we don't really have, that's a good point too, right? Well, they see, that's what they call it, that's something perverted, right? So I don't know if I want to look at that, but what they call it, they got something in European, they got something in European psychology where the European, because of how they think, the son wants to have sex with the mother. Like that's the type of relationship, psychological relationship they have. So you have Jesus and you have Mary, and they have a relationship. Now that's an incorrect relationship how they have it in the Bible, because it's actually the Black Madonna, and it's what they call that black woman Mary, but I think that's really supposed to be Osset and her son Horus, and then they don't even show you Osar, but you got to look at how they give you the story of what happened to Osar. But my whole point is that Osar and Osset are supposed to represent, well, who would be Osar, right? That would be, who was Joseph? Joseph was the father of Jesus, right? But that make a lot of sense because he was from Judah, right? So we don't even, and again, how they give you a Saul, I don't even know if they give you a hieroglyph of what a Saul looks like. But these are Muslims, how we supposed to be living in Commission society. I say that because you get Jeru from Haru. Haru is Horus, and that's just the son of Asar and Aset, right? But then you got Salam. And we still have the argument. Well, it's not an argument, but you know, they go back and forth. Arabic came from the hieroglyphs. The hieroglyphs came from Arabic, right? So that's still the argument to keep the black man and black woman from really understanding in the beginning God created the heaven and the earth. Again, if I'm a devil and I'm anti-law, whenever Judah comes out and professes the law, I burn in the hellfire. They say in the scripture that God say that they have no sleep unless they cause the righteous to fall. You understand? Like, you got to understand God gives us sleep to rest. So you got devils listening, right? They're always trying to steal a hearing. They're actually slaves to a higher devil power that controls majority of what we, like again, we're on their playing board. But can you imagine, brothers and sisters, you wake up at 3 and 4 o'clock in the morning and they still there? You can hear how tired and ragged they are in their speech. Like they still trying to talk to you and harass you, right? Beat you in the brain. But you didn't just got about 3 or 4 hours of sleep. And inshallah, you about to go back to sleep. They're not about to go back to sleep. They about to stay up. So you got to look at your victories now. When God be right there waiting for you in your dreams, where you don't get no sleep. What kind of nightmare is that? To be living that nightmare. But so is salam. You find salam in the Quran. But if you really look, you find salam on the planet, meaning peace. But that salam is just a translation of Islam. That's the same word. So you're talking about Horus, Islam. And that was a place on the planet. So again, I say all that to say that it's Islam. All praise to you, Allah, Lord of the world. Okay. So that's just a little, I seen that, and I wanted to just show that to the people. And okay. So I say that to say again, the nation of Judah, the black man and black woman in America with a 400-year history of slavery, always understand now, Deuteronomy, what is it, chapter 28, verse 48, and God says that he will put a yoke of iron around the black man and black woman's neck in America until we are destroyed. So we are destroyed. But then God say in Zechariah 12, God say that I will send the word, right? But God came. See, again, I think how we got on Master Farad Muhammad is that when you see us in society, we're always waiting for a king, or we're waiting for God to come. Unless we got knowledge, right? But God done already came. And God came with that knowledge, right? And he came, like it says in Zechariah 12, God say, because we have been beat down with a 400-year history of slavery. Okay, so let's look at it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 12 is going to be Judah. The nation of Judah. And the nation of Judah is the black man and black woman in America. With a 400-year history of slavery, the Bible says we have been destroyed. So Judah is destroyed. But from the language of the Bible, these nations of black people, these are I'm going to say, the believers, or you can say the original inhabitants of the planet, the human being. We can say it like that, right? We can start looking at it. I'm going to say that the nations of Jacob are the human being, which is correct, because they go back to Adam. But then we got to be more specific, right? We got to say, I'm going to say these are, well, you can't say that because we're not necessarily, this might be correct. As far as the lineage of Adam, how God created Adam, right? You got to look at that too, right? But to stay focused, Judah has 11 brothers. And none of these brothers, I think you could talk about, let's say this one right here is Benjamin. Benjamin, now I don't know all 12, but we're going to say Benjamin. Benjamin is Jamaica. Jamaica. I might be spelling it, what is Jamaica? That might be correct. And then we're going to say one is Levi, and Levi is Haiti. Haiti. Might be Haiti. Okay. Okay, so let's just understand, right? Now, I don't really know, all of these nations have been afflicted severely in some way with the devil coming out of the caves and hillsides of Europe. You're talking about 1555. With the holiday that they were just celebrating with Christopher Columbus, they came out of the caves and hillsides of Europe with their knowledge from the Muslims, from Prophet Muhammad, and they afflicted severely the black people on the planet, but they severely afflicted the 12 nations of Israel, right? And all of these, you got some of these nations that have been outright murdered. Well, there ain't maybe 2 or 3 of them, right? When you start talking about the Native American, or what they call the Western Indian, right? So when you start looking at them, they done been murdered. Whereas just a few of them. But they ain't never had that chattel slavery, correct? So on some levels, they still got how they think. They still think kind of correctly. When you talk about one dimension, you talk about 2 dimensions, then you talk about multi-dimensions, or 3 dimensions. Right? How you think. Okay. So what I want to say again is that it was unimaginable horror what these devils did to the 12 nations, to the black man and black woman on the planet. Okay, but then Jamaica didn't really fight a revolution to get their independence. Well, they are a black country now, but they was very aggressive, and they was about to get busy, so they had to fold. The Caucasian had to give up, but they still necessarily control that in another wicked type of way, right? Okay, but that's now 400 years, but that's like maybe 2 or 3. That's going to be some slavery there, right? Chattel slavery, and you always understand they went here first, and this is really where the homosexuality comes in at. Where these brothers on these islands, that's a severe abomination, brother. Like, when you talking about Judah on like a continent, it's a lot of room to move, so that filth can kind of expand, right? Where it's not compressed, where that pressure can kind of like dissipate. So we still here in America. 400 years it took the Emancipation Proclamation. But when you talk about an island, right, you got this homosexual from Europe, and he raping these slaves, men and women, that's too much pressure for that type of filth. God is not going to allow that to exist. So God raised that spirit up in these black people. So you have the Haitian Revolution, black man Muslim, walking around with the Quran, organized, and they revolted, the first black. Okay, so my whole point is that in so many ways, the brothers of Judah, even though severe affliction from the devil, they still have and then look now, Levi got busy. The black people in Haiti, they took out their frustrations on that devil. So they got some strength. As you know, if we have a reunion, right? You see what I'm saying? We have a family, a Israel family reunion, and the brothers come together. It's going to be Judah that's going to be in the wheelchair, severely afflicted. Well, everybody else going to be pretty, I'm not going to say they're going to be strong like how we used to be, but they're going to be pretty much strong. So I say that because, again, when you go to Zechariah 12, God say that he going to give the word. He going to shine his eyes. He going to lift Judah up first. So the only thing, brothers and sisters, that make us strong, they looking at us crazy, but they ain't crazy, is what Master Farad Muhammad brought to us in 1930. That's what God said in the Bible. God said, I will come to you first and give you the word to strengthen you when you go amongst your brothers. Okay. Okay. So I just say that again to get us back in the Bible. And I think in so many ways, the Bible is our salvation. But it's a correct interpretation of the Bible. You have to have a correct interpretation of the Bible, and you can only get that from what this brother brought. Judah, again, Zechariah 12, the book of Zechariah in the Bible, chapter 12, within that chapter, God says that he will shine his eyes on the house of Judah first, and he will give them a word that he has not given no one else, so that the house of Judah can protect themselves against their other brothers. How is that like, you know, okay. Today gonna be kind of like off balance, because I got a test today, and I think we're just gonna talk about what I have a test in today. And so I'm gonna lay the foundation a little bit now. What I put on the board, I'm gonna do, we had like I got some problems that I just wanna look at before I actually go take this test. I don't wanna fail the test now. You know, even though I know it, right? But then you don't never know what you really know until you see it, until you get that test. Okay, so I'm gonna put things on the board, and I'm not gonna really necessarily show a derivation or explain it, right? But it's just me preparing for when I go into this classroom to give this information. I say that because, you know, you might not know something and you say, well, why he not explaining it? So don't worry about that. Just understand that what I want you really to look at is this now. We're still talking about math analysis. Now, we're going to get to it, right? This is called, I love this. The first class I ever took was differential equations. Now, ever since I left graduate school for physical chemistry, when I first started taking my physical chemistry class, like again, I'm a theoretician. Like I come up with theory, right? But a lot of times it's the language. So when we were talking about ballistics, I don't know if you can see it, right? But when the brothers had the math, where they were going to actually start showing you, when you talk about a trigger mechanism, when you have that math, right? So you understand it, right? That's what it is, right? But when I was doing physical chemistry, I'll never forget, right? They had a nice physical chemistry book, real nice and everything, right? But one of the most basic things, they had a thing, right? It was just like the partial derivative with respect to x is equal to some number, right? And I sat there and I was like, it was real basic. Like it was so basic, it was ridiculous. And I sat there and I looked at that and I even tried to, like, I'm still a researcher. Like I know how to research, but it was just so complicated. It was just real, it was horrible. Okay. So now I'm talking about, well, I'm gonna go get my doctorate in mathematics. The language of communication. When you see young people and you talking and you speaking to young people, to have that mathematical foundation where you can communicate with articulation, what we need is what we need. I need you to progress. I don't need you to deprogress, because I'm progressing, inshallah. I'm going to make my prayer. I'm going to give charity. I'm going to fast. I believe, inshallah, I get enough finance. I'm going to where? I'm going to my ancestries. I'm progressing. You're not progressing. to the point where you become some type of plague, right? Where God, I no longer see you. That's not doing me no good. So to see us progress. Okay, so that's the language, communication language, get you to understand. So when I came back into the college environment, the first class I took was differential equations. And again, brothers and sisters, I just love differential equations. And the reason why I like differential equations is because when we do talk about progression, you don't have no, we're going to pick on finance. You don't have no finance, you got to progress to $1 million. How is that impossible? If God already say you need $1 million, if you have a history of chattel slavery and you amongst the planet of people that got finance, what God say you don't, and then if you in righteousness, you need to do charity. You need to have some place for your wife and your children. You need to have a place where people come and make prayer. Right? That's another thing too, right? The Bible say that in these times that we're living in, these are some very horrible times. Where you live, how you live, you have to create how you live as a place of worship. When I come to your house, or when I come to wherever you are, do you have a place where I can make prayer? You need to look at yourself and answer that question. You got a place where I can watch television, football, right? Boxing, love boxing, right? Potato chips, we gonna eat good, whatever you want. I can do all of them things. Ain't none of them things in the Bible. You can't even find none of them things. It ain't even, don't even pick on the Bible, Fatiha. You can't go to no scripture where the scriptures say, well, look, have a couch, make it leather and everything, where you can just eat potato chips and watch sports or entertainment. No, you don't have no scripture that says that. But the scripture says that in these times that we're living in, can Mr. Sharia come to where you are and make prayer? No. You're going to look at Mr. Sharia. You have no place in your house. Your house is a temple. There is no place in your house where I can come make my prayer. Whenever I get up and I say, well, look, I got to excuse myself to make my prayer, you're going to look at me like I'm crazy as hell. Like, what the? It's going to be to the point now, you very peaceful. We are peaceful people. But when I get it, it's going to be peace all the way up until I say, well, look, I got to go make my prayer. Then it's going to change. And that's when the beasts come out. Now, you can't make no prayer up in here. You got to go to McDonald's or something. Go down the street to go to the bathroom at McDonald's and make your prayer. Right? That's not what the Bible says. The Bible say in these times, while you come to Mr. Sharia house, or you catch Mr. Sharia anywhere. It ain't got to be where I dwell. You catch Mr. Sharia anywhere. Are you trying to you trying to pray? Okay. Why do I say that? I say that because when we talk about progression, to progress from nothing to something, in the eyes of God. So differential equations, if you just look at the root of the word, it's a difference. A difference. Difference is subtraction. You got 5, you got a 3. Well, what's the difference between these two numbers? Well, the difference is 2, right? That's on a very simple level. So when you talk about a number line, and again, we're talking about motion. Always understand the planet is rotating on its axis. You have a rotation on its axis, then it's rotating around the sun. So it's motion. Motion. Listen, if you stand still forever, you'll never get there. Where are you trying to get to? Well, we're trying to get to paradise. We're trying to get to where we're communicating with God. But if you're in your ignorance, you're just standing still forever. So you ain't gonna never get to where you want to get to. So it's a difference. So you standing still right here. Then you start God. It really be the communication of God to get you to move. Always understand now, God has created these wicked devils for the day of evil. Right? So if God ain't telling you what Mr. Sharia is communicating the prophets, God ain't telling you that, then what is God doing with you? So God ain't telling you nothing, you just standing there. Then God start giving you the word. So you go from X sub 0, we're going to call this point A, or X sub 0, you start moving. That's a particle, right? Particles move so fast, we can't even see them. Or you can say the speed of light, right? I think the speed of light move at, what's that, 2.9 meters per second squared. That's actually that's the speed of light. Very, very fast. So we look at a particle, how fast is that particle moving? So you go from X sub 0 to X sub 1, right? So how fast has it went from 0 to 1? So that's a difference. Right? And that'll let you know how far and how fast the velocity, meters per second, or how has it accelerated, meters per second, or second squared. And let me show you this right here too. I put it on the board. I had an opportunity to explain it, but I didn't. So when you have, I said, okay, now look at this now. Meters per second squared. I said this is meters, because this is kind of, it's not difficult to understand, but again, the literature, they never tell you what it is, brothers and sisters. It's a hustle. You're always being hustled. They got these brothers and sisters, they are advertised, well look, you get a doctorate in basket weaving. Don't never give you no scholarship because you ain't really learning nothing. You get straight A's, but what you getting straight A's in? But you getting a loan. You win the trend. You got on a fresh pair of Jordans. That's the trend. Well, you in college getting loan. Like you see what I'm saying? They make it a trend. That's the fashion. To get a crazy ass loan that put you in debt for life. But that made that fashionable. So it's meters per second. So you got velocity. Remember now, it's just X in space. It's not doing nothing. It's just a position in space. Then it moves. So it moves a certain distance over a certain period of time. That's meters. That's time. So it moved a certain distance, meters, over a certain period of time. So that's meters per second. That's velocity. But look now, so then you have that, say that's a group. You call this G. And now you have group G moving in time. And you say per second. So now, look now, you have X. X was just a position in space. Then it started moving a certain distance, which is meters, and it went a certain amount of meters over a certain period of seconds. So that's meters per second. And we call that system, that's a system. We call that G. So now you have G going a certain distance, meters, per second, but that's in a group. Okay, I did that incorrectly, right? That's a good point. You have meters per second, which we call G, and then you have G moving in a certain period of time, oh, we're going to look at that, right? Because that's what it is, right? So that's how you get, well, from my language. Well, let's look at it, right? So you got meters per second per second. Now you can't add, if they don't look alike, they're not equal, right? Because understand, even though it's a 1 there, the 1 you don't see the 1, right? Because we don't write that, but it's a 1 there. It's understood for a 1 to be here. So you can't add those, you can't add that together or subtract it, but you can multiply it. And when you multiply M times S, you get MS or M times S. Because they're not the same thing, you can't do nothing with it. If you were to add M plus S, it'll just be M plus S. Because they're not equal or they don't look alike. Okay. But look, you got S equals S, right? They look alike, so that means you can add them. We're talking about variables, the symmetry of numbers, to S. Let's look again now. S is equal to S. They're the same variable. So that means you can add them and subtract them. S plus S is 2S. S minus S is 0. The same as numbers. 1 plus 1 is 2. 1 minus 1 is 0. Okay. But we're not adding or subtracting. We're multiplying. Right? So we say S times S is equal to S squared. Let's look at this now. Say we say 3 times 3 is equal to 9. But then we say 3 squared is also equal to 9. So how we call this, when you see a number in this position right here, the upper right position, we call that a power. A power position. So if I say A to the 4th power, that has a power A, the variable A has a power of 4. That's a power position. So let's understand now. We say meters per second, and when we say we have S with a -1, that means that S is in the denominator. Remember, you got the numerator, you got the denominator. So we said S equals 1, that's just S over 1, or S. When we say MS -1, the M is in the numerator. The -1 puts the S in the denominator. Right? So you learn in studying mathematics, if you got S in the denominator and you bring it up, well, now you got to make that a negative. So you have M S -1. Now I did that very fast, but just stay focused. So you have meters per second. That means meters per second, right? So you have meters per second. Take a look at that. Meters per second is meters. If it's negative power, if the variable has a negative power, that means that variable is in the denominator per second. But how do we get meters per second equals meters per second squared? Now the tricky, it's not, I mean, you get to learn it, but initially it's tricky, right? Because we're talking about multiplication. It's meters times per second, which is meters divided by second times second. Now what we want to do is just focus on the per second times per second. It's multiplication now. It's not addition. It's multiplication. So when you multiply two variables, you're adding the power. I'm going to say that again. When you're multiplying two variables, you are adding the powers, right? So say we had S3 times S2. You don't multiply it intuitively because it's S multiplied times S. Well, we multiply 3 times 2. And we say that that's S to the 6. No, you'll get that incorrect. You don't multiply the powers, you add the powers. So you have two variables that you will multiply. This one variable has a power of 4. The second variable has a power of 2. That's not 4 times 2 equals 8, S to the 8th power. You add 4 plus 2 when you have S to the 6th power, right? So I just done told you something, right? How we always get hustled in America. Look at the hustle now. I just told you that S to the 4th power times S to the 2 power is equal to S to the 6th power. And we be cool with that. Oh, now you got to prove it. You got to go to math analysis and you got to prove it to make sure you're not being hustled. I'm about to tell you anything. Now we're not gonna prove it using like math analysis with theorems. I'm just gonna try to show you with numbers. This is called rigor. This is like the lazy way, right? But again, we're trying to keep it moving. So say you have 3 times 3, right? You got 1, 2, 3, 1, 2, 3, 1, 2, 3. If you add this up, that's 9. If you add this up, that's 9. You got 3 sets of 3, so that's 3 times 3. That's how we get to 3 times. You got 3, 1, 2, 3. You got 3 sets of 3. So that's 3, 1, 2, 3 times 3, 1, 2, 3 to give you 9. Or you can just count. That's another good thing too. When we get high up and we really start looking at these diseases, you can really just use arithmetic. But they done got us away from that. Just like they got us away from the Bible. So they take you away, brothers and sisters, from the originality. They take you away from you and put you in some devil. Well, you crazy in your mind. But you can really solve whatever you want to solve with arithmetic. You got to have that knowledge. Okay, so it's 3 sets of 3, which is 9, but you can also write 3 times 3 is equal to 3 squared. We're proving that negative s times negative s, s to the negative 1 power times s to the negative 1 power is equal to s to the negative 2 power. We're proving that using numerical values. So 3 times 3 is equal to 3 squared. 3 squared is 9, or you can do arithmetic. 3 sets of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But what we want to prove is if we have 3 to the 1 power times 3 to the 1 power does that give us 3 to the 2 power? With the algorithm that we're showing that whenever you have variables or any numbers in the number system, variable A, they first have to look alike. A to the 3rd power times A to the 1 power is equal to A to the 4th power. Right? That's hella confusion. Right? Because you want to say 3 times 1, which would be A to the 3rd power. No. It's not what it is. We've already proved that 3 times 3 is equal to 9. Now understand now it's a 1 in the powers place. 3 to the 1 power is equal to 3. That's why we can put a 1 there. It realistically might not be no 1 there. That's what makes numbers so powerful. But because it is 1, we can say 3 to the 1 equals 3, and 3 to the 1 not take away from the fact that it's equal to 3. Okay. I just realized that's powerful. Okay. So, you got 3 times 3 equals 9, but that's 3 to the 1 power times 3 to the 1 power equals 9, right? So you say 1 plus 1 equals 2, so that means that it's 3 to the 1 power times 3 to the 1 power equals 3 to the 2 power, and so 3 to the 2 power is equal to 9, and we know that's 3 times 3 equal to 9, which is 1, 2, 3, 1, 2, 3, 1, 2, 3, the addition equal to 9. So therefore, s to the negative 1 power times s to the negative 1 power, if you add negative 1 minus 1, a negative minus a negative equals a negative, which is negative 2. So s to the negative 2 power. So that goes back to velocity is meters per second. Meters per second. That means that it's meters divided by seconds, which is meters per second. Whenever you see a variable or a number, or really a variable in the denominator, you can bring that up. It's just a negative, it's a negative power. Whatever power was on that variable, right here the power was 1, so it's a negative 1. But now we're talking about acceleration. It's meters per second per second. So we say that's meters per second squared, and we say negative 1 minus 1 is equal to negative 2. So that's how we get the negative 2 in the power position of the second variable. And so we have meters per second squared. Squared, the seconds is in the denominator. If you bring that up, it's meters per second with a negative. Now that 2 is a negative 2 to show that the seconds is actually in the denominator. Okay. So I seen that, and I wanted, that was a good tutorial to get my teaching skills going. Okay. But we counting down, brothers and sisters, and I want to make sure I do have some type of grasp on what I'm speaking on. And I wanted to get into, I don't think we're gonna be able to speak on it, right? But we were talking about ballistics. And again, that was just differential. When we started getting into the math, and we stopped at, we were going to differentiate an equation, the difference, the motion. Always motion. What's the change in going from point A to point B? What's the change in going from point A to point B? Always understand when you talk about, when I think about differentiation or differential equations, I think about a flower. Say you got a tomato plant, right? At time 0, the plant, I don't know, it's only like, what, 3 inches? No, it ain't even that much, right? Well, yeah, you could say, I ain't gonna say 3 inches, I'm gonna say probably 2 inches. Say we say time 1, you could say that could be first week. Now it's at 4 inches, right? It's a little bit bigger. The leaves then got a little bit bigger. Start, and you see some new growth. Then say you say time 5, it's like 8 weeks. It might be at maybe 2 feet. So now you start talking about you got a tomato plant, right? You might actually see some buds coming on that jump with that thing about the shape, right? So you're talking about, now we still talking about distance, but it's a different type of distance. What's the growth distance? From this size right here to this size right here, right? That's in 7 days. But then what's the growth difference in this size right here, T1, 1 week, compared to 8 weeks, right? So that's when you're talking about a differential equation. What's the differences in growth? So if you talk about a tumor, say you're talking about a cancer tumor, at T sub 0, right, it's a certain size. 2 years, it gets to be a little bit bigger, right? That's T1, right? And you talking about 10 years, if you still got that cancer tumor, you're gonna start to really feel it in your human being system, right? So that's what differential equations is. And when you start talking about the military, and it's just acceleration. Anything you think about velocity, we going at a certain pace, 55 miles an hour. I don't know if that's velocity though, right? Because you can start talking about what that is. Well, no, that's speed. That's when it get to be kind of picky, right? But we want to always focus on acceleration. I said that kind of incorrectly, right? Because we still want to be patient in our endeavors. And I equate patience with velocity, right? Just going at a steady pace. If you're talking about Cartesian coordinates, velocity is just a straight line. That's patience over time. But then acceleration, right? Okay. So let me just get into the problem, because again, brothers and sisters, I'll just be talking, right? But this is actually real good. This is gonna be real good. Okay. So let me see where I have it. I actually got it on this. They got something where I can hook up. I hope I ain't got to sign in again, do I? I might have to sign in again. Oh, I got to sign in again, right? Okay. So let me go straight to this information. And we're going to put this problem on the board. And what we're talking about, we're talking about the travel of heat. Now I took it off the board, right? You got differential equations, and then you got something called partial differential equations. Partial differential equations. Partial differential equations. So again, when we talk about a difference equation, we're talking about going from point A to point B we're looking at that difference in between that. And we're really using all of this to calculate acceleration of atoms. It's a subatomic world that we're really looking at. For that heat, you need that heat in so many ways. So you got differential equations, which is just one variable. I'm going to put it in that language. But what if you got two variables, x and y? And say that the y variable doesn't change. So you got time 1 or t1 is equal to y. t2 is equal to y. So at t1, that's a certain time, it was y. At t2, that's another time, it was y. But let's look at x. At t1, it was x. But at t2, let's say it was at x sub 1. So it was a change in x. It went from x to x sub 1. But there was no change in y. At t1, it was y. At t2, it was y. So remember the symbol now. This symbol means it's a change or a difference. So we had a difference in x. We didn't have no difference in y. Right? So now that's a partial difference. Partial differential equations. It's a partial difference. It's not a difference in both variables. It's only a difference in one variable. And that one variable is partial of this x, of this f, xy, this function. So we got to solve this. So this might be, so you might have something like that. The function of f of y, the function of xy equals the partial of u with respect to x plus the partial of u with respect to y. Now when you see something like this and you see a variable in the numerator, u is just another function of some separate variables. That thing get to be real beautiful. Because we're talking about systems. Always understand now, we're talking about systems. And then when you come up into the Research Library Corporation, we're talking about number theory and the universe system. We're talking about the universe system. So you're looking at what God given us to describe the beauty of God. When you start talking about the book of Genesis and God creating the sun and the earth and the heaven, and really just giving life to people. People be dead spiritually. So that thing get to be real good, right? Okay. So let's just get into this problem. And I talk about heat, right? Right? You say, oh, he always picking or something like that. No, but look though. What we about to study, I'm about to take a test. It's called, the name of the class is called Applied Application. Applied Partial Differential Equations. That's the name of the class. So we're going to use partial differential equations. We're going to apply that knowledge to studying heat flow. How does heat, how does it flow? Like, and whatever. But we got a system where right now we're looking at how does heat flow in a cylinder. And we're looking at the heat flow within a cylinder. Okay. So the heat equation is the partial differential of u with respect to t equals some constant k, the partial squared with respect to x squared. That's the equation, the generalized equation. So then you have initial conditions You have boundary conditions. You can freak the thing however you want to freak it. But they're giving us boundary conditions. So what I think initially, okay, so we have a 2 here. We have a 2 here. This is going from 0 to x is greater than 0, less than 3. We got boundary conditions. 0t equals 0. Then we got the partial of u with respect to x. 3t equals 0. Then we have initial condition of u of x equal to x to the 4. And we got to solve for the eigenvalue greater than 0, just greater than 0. We have to use the method of separation of variables. Okay, let me make sure I got everything straight so I can just solve it, right? 0 partial. Okay. Okay. So given these boundary conditions, I'm going to tell you again, this is so much fun. We talk about things that's better than sex, right? When I was doing when I was in the community college, right? When we were taking, that was calculus 3. Calculus 3, oh, that calculus 3 was off the hook, right? But we had he was a younger professor. He was a good professor for students. A lot of time we just be so friendly, unfriendly, and ignorant. But he was a good professor for students. Community college is actually very good. Regardless of whether you're good in high school or not, you should go to community college first. But, so, you know, it came a time, then we in the class, like we was doing Zoom because of COVID, right? And, well, from the after effects of COVID. But you know, the young people in the class, right? So because he was younger, you know, he just living a life, right? Going to movies. So I think one time, I was like, I'd rather take a test. I'd rather take, because we had one of the things, right, where it was like, do y'all want to take the test or y'all don't want to take the test? So, you know, everybody in the class is a young student right now. We ain't trying to take no test. But I was like the only one like, no, we should take the test. So I was like, I'd rather take a test. I don't know if I said have sex, but I said something like that, right? Everybody started looking at me crazy. And I remember he said, like, he heard me, right? He actually heard me. And he said, nah, I don't think I would. He was like, nah, I don't think I'd rather take the test than go to have sex or to go to a movie or something, right? So that's just me, right? Like, there's so much things better than sex. This thing right here off the chain, right? Okay, so let's solve this, right? So we got to solve this equation right here. The partial derivative of u divided by the partial derivative of t is equal to 2. 2 is a constant, equal to a constant. The partial derivative squared of u times the partial derivative of x squared. Okay, so we're looking at the variable. Now t is time. Is t time? No, yeah, t is time. Because we're talking about temperature, so and x is position, a position in space. But we're talking about a cylinder. So this is the x-axis. Remember Cartesian coordinates. So we just talking about position right here. This is 0, what they say, 0 to 3, this is actually the difference. So this is 0, and this right here is 3. So we're looking at that difference, that heat flow. How does heat flow? At any one time, at one point, we can look at what the heat is doing. Assumptions, right? Until we actually perfect it. Not saying it's not perfected, but we have to look at it. So we use this equation right here. This is the standard form. So we got to define what U is. We don't know, like, the whole thing, what I was trying to tell you initially, is when you talk about a function. They're using U right here, but we say f of x. But they have the variable U. You got to define what that function, it's the function, the system. How is the system being described? The activity. So you can put numbers on it. When you talk about cancer. How do you dissipate cancer? You can just dissipate cancer. How you mean to tell me that, brother, we so cavemen, stones, it's a cave. They live in a cave. That we got to cut the human being open, send all types of disease. Now, I'm not saying them things don't save lives. Allah forbid, right? And then it didn't save lives. But just the animal mentality. Well, you just can't, brother, you can't go inside a human being and get it to dissipate. No, you don't know the function. That's why you can't do that. You got to know the function. So when you talk about differential equations, well, what's this function? If you don't even know what the function is, you nothing. You're going to have to make it up. But when you get in that spaceship and you talking about you done made it up, you don't know what it is, you can only imagine. So I took it down. We say separation of variables. They got something they came out with. It's genius. Well, it is genius, sort of, kind of. It's rudimentary when you have a command. When you get your hands around it, you can do whatever you want to do with it. If your hand's too small to get around it, then you can't grab it. But once you get your hands, so they got something called separation of variables. So we don't know what U is, but we're going to make it into something. So we say UXT is equal to X. This is kind of genius, right? At that basic level, right? We just define U, because we don't know what U is, as these two variables right here. And then we got to solve that, right? So this right here, I'm just going to go through it, brothers and sisters. I'm not going to really give you a derivation. And then we say this right here. I wrote that wrong, right? See, I be making them type mistakes, brothers and sisters. I be making them type mistakes. It be costing me points. Okay. So we got this part right here equal to this right here. And we got this part right here equal to this part right here. So then we just rewrite that, right? We say and you got the 2 right here. So we took this equation right here, and we just translated it. We defined what U was, right? And once we define what U was, they call that the separation of variables. Once we define what U is, then we apply this partial part. This is a symbol. It's called a partial differential symbol. That partial differential symbol is like an algorithm of rules that you're supposed to do with a certain set of numbers. You have to learn those things. So when you apply that to this function, you get this right here again. I'm going to write it again. Which comes from this right here. Okay, so now we have this equation right here. We do some simple arithmetic. Well, we divide this to both sides. And we divide this to both sides. They cancel, they cancel. That gives us all we did was just divide. We divided the variables throughout or rearrange. We come out with this right here. Now this right here equals some constant. Again, we're just making up some more stuff because it adds up. We can say that this is the Greek letter lambda. It could be any variable. But what we have to understand is that we're using variables. But look, A divided by B, that's all this is. Even though we say T, I don't even know that language, right? Even though we say the partial derivative of T with respect to T times 2, even though we say that and we use them variables, that's just like saying A equals B, right? Or like that's like saying M equals T. But you have to keep it structured so you don't get lost in your calculations. I say that because you have the first derivative, partial derivative of T with respect to T divided by T times 2 equal to the second partial derivative of X divided by the function f of X, and we just set that equal to A. But we say negative A because we have to make the calculations come out a certain way. I don't really know the theory. I mean, I know the theory, but I don't know the actual derivation, something I have to learn. But lambda is just a constant. So then what we do is we multiply. Right? And we multiply again. Right? So now we got two separate equations. And what makes this powerful is because it's very difficult. Remember now, we did partial equations. Partial derivatives. In this situation right here, K is equal to 2. That's a partial differential. We got two variables, but we done broke that down with this method of separation of variables. Remember now, we said it was the one equation, the one function. This one function is now equal to two separate functions. Then we took it through the algorithm, and now we have two separate functions of a single variable. That's a whole lot more simple. Now, I don't know the in-depth. Again, I'm not at a doctorate level. But supposedly that's supposed to be simpler. So now we have these two equations, and we have to solve these two equations. Now, if we go back to the initial conditions, they say that lambda I should have raised that right. But they say lambda equals greater than 0. lambda right here, we're going to start off with this right here. This lambda is greater than 0, so we learn, right, it's a form, it's a certain form against symmetry, how you solve these equations. So when lambda is greater than 0, we have an exponential that's equal to RS. Both them variables is just variables, but you find out that R is equal is plus or minus. But R, when lambda is greater than 0, is plus or minus I lambda. Right? That's not complicated, but that's some more talking, right? But just to solve the problem. So when you find out what R is, right? So now you got the exponential plus or minus I lambda x, or some variable, but it's x in this situation because we're talking about the spatial function. You can rewrite the exponential to be a constant cosine lambda x plus c2 sine lambda x. I'm going to write it again. When you study differential equations, they have something called an exponential. And an exponential is just, instead of having a number raised to a power or a variable raised to a power, the exponential e has a value. And I think that value is an irrational number, but the first couple of numbers is like 2.1735. So whenever you see an e like this is what the value of that number is. So it's more or less a power of this value, instead of saying like a to a power, where a is a finite number. A can be anything to raise to a power. But now we have e, which has a value. It's like pi. Or like, what's like pi? Pi is 3. Pi is another irrational number. But it's sort of like pi. But we use exponential. The reason why it's important is because when you take the derivative, or when you take the difference of an exponential number, say we're going to say with respect to x, right, and it's just ex. When we take the derivative of ex, that's just equal to ex. So no matter how many derivatives you take, it's still going to be ex. So that's why you can use this mathematical form when solving differential equations. It gives you this form right here, exponential plus or minus R or S, and they have found a way to take the exponential and make it equal to just sine and cosine waves, which is real powerful. Because now, that's so powerful. I mean, you know, again, that's just powerful because you're taking a finite function, and if you can apply this system, now you're putting boundaries on the function, you're making it, it's just real powerful. Okay. So that's what they have done, brothers and sisters, and that's what they are doing. That's what we're going to learn how to do, because Judah, black man and black woman in America, the lawgiver. Okay. So when lambda is greater than 0, we got C1 cosine lambda x plus C2 sine lambda square root of lambda x. Okay. Now we got to find what they call this an eigenvalue. We got to find what lambda is. Let me get my thoughts together, right? So we look at the initial conditions. Now look now, we started out as a partial, so they give you two variables. But we done changed it up now. The t variable is this right here. We're not even talking about that right now. We're talking about this right here. So we got x equal to 0. Look at it. Say u, remember u was xt. Now x is equal to 0. T is not relevant in this equation because we just have x's. So we can just disregard the t. But we got to put in an x sub 0. So wherever you see an x in this equation, you put 0. Right? So that's going to give you C1. 0 times anything is 0. So that's cosine 0 plus C2 sine 0. Cosine 0, whenever you see cosine 0, that equals 1. Remember now, let's look at the graph. The sine wave at 0, this is 0, 0. Starts at 0. That's 1, negative 1. The cosine wave starts at 1, at 0, at x equals, this is the x-axis. This is the y-axis. At x equals 0, the cosine wave starts at 1, it goes down and comes up. So at cosine 0, remember x equals 0, x equals 0, the cosine wave is at 1. So that's cosine, okay. At sine equals 0, sine equals 0, x equals 0, the x value right here is 0, the x-axis, the sine wave is at 0. So this gives see how it just simplifies real simple when you understand it. Okay, so now from the first condition, this is the initial a boundary condition to solve this heat equation. How this heat is traveling through this cylinder, one dimensional. The first boundary condition was at x equals 0. We put 0 into this equation, and we get C1 equals 0. Because it's at x equals 0, this function equals 0. C1 times 1 is just C1. C1 equals 0 because right here, U 0t, U of 0t equals 0. So when we put 0 into this equation, this equals 0. And then we get C1 times 1, which is equal to 0. Now that's a trivial solution, what we call a trivial solution. And that's real powerful. Because it helps you when you talk about math analysis. You got something called a number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you got something called a variable. So when you have a variable equal to a number, the variable is for the entire system. Okay, remember we talking about the real number set. The real number set is everything. It's not the number system. Well, the real number set is the real number set. Right? It's the natural numbers, the integers, rational numbers, irrational numbers. That's the real number set. So you can have A in the real number set. And that could be any one of these numbers. Or you got 3 in the real number set. I'm still trying to get my hands around. This is what it is right here. Let me show you again. You can have a variable in the real number set. That means that variable could be any one of these numbers. Or you got what I call a finite number. 3 in the real number set. That's a huge difference. Because you can prove a number, you can prove a statement for 3, say 3 plus 3 equals 6. But what about if we say A plus 3 equals 6, right? And then we say A equals 4. Well, if A equals 4, then 4 plus 3 is not equal to 6. You understand what I'm saying? So I done had it, because when you start proving things, you got to show that. Which is real good too, because then you talking about the entire, you showing something for the entire system. So that's a big difference, brothers and sisters. It's a big difference with saying a finite number in a natural number set compared to a variable. The variable talk about the entire system. Okay, that's important because now you got C1, a variable, equal to 0. So within the entire system of this heat equation, C1 is going to always be equal to 0. I mean, that's good. That's giving you a solution, but we call that trivial. It's a trivial solution, right? That's like a very basic foundation. You want to put them numbers in there. So since C1 is a trivial solution, we know that this right here, we can't use this. So we use this right here. And we say that okay. So now we got to use the second condition. The second condition says that the partial of u with respect to x. Remember, t didn't change, so we're not even worrying about that. We're still using this one variable function. Now x is equal to 3, equal to 0. But what we first have to do is we have to take the partial of this equation right here. So the partial equation, it's no longer a partial equation, it's now a differential equation. Remember now, we separated the x and the t. Well, we're just dealing with an x function and a t function. Right now, we're focusing on the x part. The x is the spatial part. So we got to take the derivative of this equation right here, and that's just that's what that is. Now, you know, okay, but that's what that is. That's equal to 0. So you just divide it out, right? And anything into 0 is 0. So we're left with equals 0. So then what we have to do is we have to say that cosine of x equals 0. Like, what x in the cosine function equals 0? Like, we got to know that. Which is real simple once you learn it. But to make that 0, to make this statement true, what is it? It's first of all, pi, cosine pi divided by 2 is equal to 0. So we go back to the this is at 0, pi divided by 2. This is at pi. This is at 3 pi divided by, and we're talking about a circle. Right? That brothers, I'm telling you, it's phenomenal. And then you talking about 2 pi. But always understand, cosine at 0, when x is equal to 0, cosine is 1. Then it comes down right here. Then it goes down right here at pi. Then it comes back up right here at 0. So they call that it's a periodic function. And what makes this whole thing so powerful is that you're taking a regular function. It could be x plus 2. That's finite. But if you can change the coordinates and get it to have a period characteristic, periodicity, whereas it's periodic in nature. Like, you don't even understand that thing is powerful, because you got a regular function, but now you can put a periodic nature on it, where this function was going to stop right here, but you converted it, where you can just have it go on and measure. And that go back to the stock market. That's just real powerful. That's powerful. Okay. Okay. So, when you have, what did I say? You took the derivative, we took the derivative, what was that? Negative lambda cosine square root of lambda x. So we say that cosine lambda x equals 0, but it's cosine lambda x3 equals 0. Remember now, when x is 3, it's x, so we gotta make that 3. So when it's pi divided by 2, cosine equals 0. So you're talking about n pi minus 1/2 divided by 3 pi, right? So you take the pi out, what's that? N minus 1/2 divided by 3. Okay, so to make this statement true, or to make this statement true, where it's equal to 0, and this is 3, we just found the eigenvalue, where the eigenvalue is pi n minus 1/2 divided by 3, and because it's under the square root, we have to square it, but you can just check it, brothers and sisters, and n is equal to 1, 2, 3, 2. N is a natural number. So say if we say n equals 1, and we multiply the pi throughout, so we got pi n minus 1/2 divided by 3. We're going to take it out of the square root, so you don't even worry about that. So you get pi n minus pi over 2 divided by 3. And when we say n equals 1, that's just pi over 2. You multiply the 2 out, right? You got 2 pi minus pi over 2, right? So that's pi over 2 divided by 3, or pi over 6, right? But you can do it like this: 1/3 times pi over 2, right? And cosine pi over 2, that's a good point too. I'm gonna look at that, because I got pi over 6, right? I don't even know if I got, hold on, son, I got my calculator too. Hold on 1 second, brothers and sisters. If we say cosine, I think pi divided by 6 is a 45-degree angle, right? Cosine pi divided by 6. Okay, yeah, so I don't know, right? No, that is correct, right? Okay. What happens, brothers and sisters? Okay, and we're going to just close up with this. I'm going to show you this right quick, inshallah. We say cosine the square root of lambda times 3 equals 0. We have to prove this statement, meaning we have to find a variable. We have to find a value of this variable to make this statement true, equals 0. Well, that's very simple to do when you talk about cosine or trigonometric functions, because the cosine wave is equal to 0 at certain points. Pi. So at certain points, the cosine wave equals 0. So we just have to make it equal that value. So we put that in here, and we say that pi n minus 1/2. But what I didn't realize, we have a 3 out here. So these 3's cancel, and you have pi n minus 1/2. So that's pi n minus pi over 2. So we say n. Remember now, n is just a natural number. It could be whatever. It's a period function, a periodic function. Means as far as n can go on and on and on, it's still gonna be this. It's gonna be this right here. So you always gonna have it equal to 0, no matter how far you go down. But you got pi n minus pi over 2. If we say n equals 1, that's just pi minus pi over 2, which will give you 2 pi minus pi. We just multiply the 2 out, the simple fractions. 2, and then 2 pi minus pi is just pi divided by 2, but pi divided by 2 is equal to 0. So when we say lambda is equal to pi n minus 1 divided by 3, if we put that, then we square it because it's a square root. If we put that value into this right here, you will have this right here, cosine pi n minus 1 over 2 divided by 3 times 3. They cancel. And so then cosine pi n minus pi over 2, that equals 0, which is what we wanted. So that's called an eigenvalue. And that's the eigenvalue for an initial boundary condition. We did all of this with initial conditions. And the final initial condition was that x equals 3 to understand how this heat is flowing through this cylinder. So that's just the first part of the problem, brothers and sisters. That's actually very good. I can never thank Allah enough for that. Like that's powerful. So what we did was, we found the spatial. It's a time component, and it's a spatial component. So we just found the spatial component, and we know what that function is now. That function is C1 sine lambda x. Now look now with the initial conditions, 0, x equals 0, x equals 3, we had to calculate that lambda was pi n minus 1/2 3 squared. That's called the eigenvalue. We had to find that. Then we put this lambda into this equation, and that gives us C1 sine pi n minus 1/2 x 3. Now the only thing also confusing, that was just the initial conditions to get us to this equation right here. But then we go back to the regular x value. Well, we still keep the 3 in the denominator because those are the initial conditions right here at the endpoints. So with those basic initial conditions, we go back to the, remember now x is any value up in between 0 and 3. So we put the x back there, and that's just again the spatial component. We drop the coefficient. And then we have to find the time component function. And that's just again, it's okay. A'udhu billahi